Good day, thank you for joining us. Today, we'll be looking at geometry of 2D shapes, particularly quadrilaterals. So we'll be looking at different properties of certain quadrilaterals, but first to start with the basic property of quadrilaterals is that it says that angle A plus angle B plus angle C and plus angle D is going to be equal to 360 degrees. What does that mean? That means that the sum of every single angle inside of a quadrilateral equals 360 degrees. So if I add every single angle inside of here, that will give me a total of 360 degrees. So obviously that would be our statement initially, and our reason would then have to be that sum of angles of quadrilateral, which can be written as quad, obviously with a dot over there, is equal to 360 degrees. So that's sum of angles of quadrilateral equal 360 degrees. Moving on to parallelogram, just to quickly get through the different properties. The first property is going to be both pairs of opposite sides. Both pairs of opposite sides are parallel. Cool. So you can see that's represented by the arrows over here. So this one has one hat. This one also has one hat, which means that these two sides are parallel. And this side has two hats, and same with this side having two hats, which means these two sides are parallel. Okay? Then if we look at the next property, it says both pairs of opposite sides are equal. So both pairs of opposite sides are equal. Cool. So when it comes to parallelogram, we'll know that this side is equal to this side, and this side over here is equal to this side. Third property is going to be both pairs of opposite angles are equal. So both pairs of opposite angles now, not sides, angles are equal. Cool. So that means that this angle over here is equal to this angle over here, and this angle over here is equal to this angle over here. This is strictly for parallelograms, okay? Remember, we're looking at specific types of quadrilaterals now. So the last point is going to be diagonals bisect each other. So diagonals bisect each other. Cool. And our diagonal lines are these lines that are here in the middle, okay? So this is our one diagonal line, and this is our other diagonal line. So when they say they bisect each other, that means that this line over here, A to O, so that's A to the middle. Let me just highlight it. So this line AO is equal to the length of OC. So that's what bisect means. It means cut in half. So obviously if you cut the line in half, it's going to have two equal halves, which means also that this half over here is equal to the half on the other side, because that's also bisected. So the diagonals actually bisect each other, so which means that on both those lines, the two halves are going to be equal to each other. Cool. So that's the properties of a parallelogram. Moving on, we see we have a rectangle, okay, a shape we're all very familiar with. So the first property that I want to go over with a rectangle is that both pairs of opposite sides are parallel, okay? Obviously, we don't have to identify that with any specific signs like that, right? Basically because these lines are straight lines, and you can see that they are parallel, right? And the whole reason is because also this is a 90-degree angle at each corner. So that's the first property. Both pairs opposite sides parallel. Both pairs of opposite sides parallel. Then number 2, both pairs of opposite sides are equal. Obviously, these things we know about a rectangle. If the opposite sides are not equal, we're not looking at a rectangle. Number 3, that would be all angles are equal to 90 degrees. Which is obviously represented by our nice squares here in the corner to show that it's right angles. And then our final point is diagonals bisect each other. So this is another set of diagonals that bisect each other. As you know, what that means is it cuts each line in half, which means that this side is going to be equal to this side, and this side is going to be equal to this side, okay? So the lines are just cut in half. Moving on to our square over here. Same like the rectangle, we're very familiar with the square, so we know some of these properties already, but I'm going to go through them anyway. So both sets of opposite sides are parallel. Cool. Our second property is going to be both pairs of opposite sides are equal. Sorry, I didn't put sides over here. So that's both sets of opposite sides are parallel. Now both sets of opposite sides are equal. Point number 3 is going to be it's going to be diagonal, no sorry, all angles are also 90 degrees. So they don't put it there, but we can put that in quickly just so we can identify it. Moving on to property number 4, it says diagonals bisect each other once again. Obviously that's telling us that this half of the line is equal to this half, and this half is equal to this half. And then this last property, which is also very important, is going to be diagonals bisect at 90 degrees. So what does this mean? So at the point where the diagonals bisect, right, which is this point over here, all of these angles that are formed in the middle are 90-degree angles. Okay? So that means that angle 1 over here is going to be equal to 90 degrees. Angle 2 is also equal to 90 degrees. Angle 3 is 90 degrees and angle 4 is 90 degrees. Okay? So where these diagonals bisect, they form 90-degree angles all around. Moving on, we have our rhombus. Okay? So looking at our basic properties of our rhombus, right? So you can see it's pretty much a square, but it's just been skewed or slanted, okay? So what do we know about a rhombus? Point number 1 is going to be both pairs of opposite sides are parallel once again. You'll see that there's a basic trend through only most of our quadrilaterals that both pairs of opposite sides are parallel. Obviously in the next one you can see that there is a set of unparalleled sides, but we'll get to that. So both pairs of opposite sides are parallel. Number 2, all the sides are equal in length. Property number 3 is going to be both pairs of opposite angles are equal. Okay, so what's that telling us? Once again, same like the parallelogram that we dealt with. Opposite sides in this case are opposite angles, are also equal. So this angle B is going to be equal to angle D, and angle A is going to be equal to angle C. Cool. So moving on to property number 4, which is going to be diagonals bisect each other. So they bisect each other. Property number 5 is going to be, once again, diagonals bisect at 90 degrees. So same like the square, in this case all these diagonals are both these diagonals are bisecting and forming 90-degree angles in the middle of here. So angle 1, 2, 3 and 4 are all 4 equal to 90 degrees. So now we can move on to our second last shape, which is the trapezium here, okay? So with the trapezium, the first point that we're going to have is, okay, well, this is actually the only point that we have. It's one pair of opposite sides are parallel. Cool? So one pair of opposite sides are parallel, which is clearly identified to us with these hats indicating parallel lines. And of course, the property that goes with all of our quadrilaterals is all angles adding up to 360 degrees, okay? So this applies to even the rhombus, the square, the rectangle, all of them. They all add up to 360 degrees, cool? Then moving on to our last one over here, we have the kite. So, interesting things about the kite here. So it says, two pairs of adjacent sides. Sorry, the S isn't supposed to be there. Adjacent sides equal in length. Okay, so basically what that's telling me is that the two adjacent sides, like this side AB and side BC, they are equal to each other in length, okay? So basically what it's telling you is that kites are symmetrical, okay? And AD is also equal to CD. Okay, so a kite is symmetrical. So now that we know that, we can go on to the next point, which is going to be that diagonals intersect at 90 degrees. So you can see this is different. These diagonals, they intersect each other. They're not bisect. If they bisected each other, then this side would be equal to this side, okay? So the only thing that we can say is diagonals intersect at 90 degrees. So, which means that these are 90 degrees that are formed over here, okay? Cool. So these are the two properties of our kite. So now that we've gotten our properties out of the way, I'm just going to go through a few examples which can help us apply all the rules that we've learned. So moving on to this first example over here, we'll call it number 1. We can see that we have 3 angles in this quadrilateral, but we do not have x. So what do we know about the quadrilateral? Angles add up to 360 degrees, right? So we're going to go x plus 110 degrees plus 95 degrees plus 63 degrees is equal to 360 degrees. So we're going to have x is equal to 360 degrees minus 110 degrees. Minus 110 degrees minus 95 degrees minus 63 degrees. Which should give you a final answer for x of 92 degrees. So here in the first step, I gave my statement. Straight after that, I need to give my reason, okay? So what my reason is going to be is that the sum of angles of a quadrilateral, which can just say quad, is equal to 360 degrees, okay? So here you can see we found the size of our last angle over here. Let me just confirm that it is right quickly. Okay, cool. So now that we've finished that one, we can move on. So moving on to our last three examples over here, we can see that we have a 60 degrees over here and an X over here, right? And what do we know? That this is a parallelogram, okay? The reason I can tell that is because we have two sets of parallel sides, cool? Indicating to me that this is a parallelogram because this side is not equal to the side, so it cannot be a square. And because it's curved and doesn't form 90 degrees in the corner, it's not a rectangle. So I've clearly identified that this is a parallelogram, okay? And what do we know about parallelograms? Opposite angles of a parallelogram are equal to each other. So we can say x is equal to 60 degrees. And we say opposite angles of parallelogram are equal. So I'll just say are equal. So you can see how we need to use our principles that we've learned, or our properties that we've learned of these different shapes, and apply them to get answers here. So basically what I do is when I see this example, I've identified it's a parallelogram. So now I would go to my parallelogram, okay, which is on the first slide over here. And I can see that it says, where is it? Both pairs of opposite angles are equal, right? It says here both pairs of opposite angles are equal. So I know that the opposite angles are equal to each other. Therefore, I can apply that and just say that x is equal to 60. Moving on here, so I didn't actually write this down, but where I got the question from, it says that this is a rectangle. So clearly, if it's a rectangle, if we go to the principles that we've learned, let me just see if I can go back to it. So we know it's a rectangle, so we're going to go to our rectangle, and we're going to see here that it says all angles are equal to 90 degrees. Okay, so now that we know that, we can come back here and we can say x is equal to 90 degrees. And we can say angles of a rectangle are equal to 90 degrees. Cool. So now we have our last thing, which is a square. The reason I know it's a square is because all four sides here are equal, okay? So once I've identified that, we can go to our rules that deal with our square. So if I just go there, it's not this one, it would be this one over here. Nope, sorry. So here's our square, right? And it says diagonals bisect at 90 degrees. And that they dissect here in the middle, and the angle we're trying to find is in the middle, okay? And say if we didn't know if this is for sure a square, if I go to my rules of a rhombus, which is over here, I can see that it also has the same rules of diagonals bisect at 90 degrees. So I wouldn't really be risking it, right? That's why they don't necessarily have to tell us that this is a square, because square and rhombus have the same rule when it comes to this angle here in the middle, okay? So where these diagonals bisect, they form a 90-degree angle, so you can say x is equal to 90 degrees. So we say diagonals of square bisect at 90 degrees. Cool. So that was our lesson on geometry of 2D shapes, specifically quadrilaterals, dealing with their different properties, and how we can apply those properties to get answers when we are asked examples like these. So I really hope that today's lesson was informative and you've learned something. Hopefully you take away and you've written down all of the different principles that are going to be very important to you. So if you haven't, you can rewind this video and go and take them down. Thank you for joining us and enjoy the rest of your day.